Hello, and welcome to this GIS tech video on spatial queries, table joins, and relates. The learning objectives for this lecture are to describe what a spatial query is, describe what table joins and relates are, and compare and contrast various spatial querying, joining, and relating techniques through practical demonstration. A query is the basic idea of asking a question of a dataset. Queries are very common to data management in general and are not solely restricted to GIS applications. Understanding how to do queries in a GIS context is perhaps one of the most fundamental skills you can learn, as you will then be able to answer questions of your data and get potential answers to help you with problem solving, decision making, and analysis. There are many ways to query data in GIS. And in just a few moments, I'll give you a hands-on demonstration of some of those querying methods. Before we proceed with a demonstration, I want to cover some basic concepts about queries. Tables of rows and columns are the foundations of queries. In this image, you see a table of US states. A query to this table uses a very specific syntax called SQL, or Structured Query Language, that I will talk more about in just a moment. Here, however, you can see an example of a basic SQL statement. Although this may look intimidating at first, SQL statements are in fact quite simple once you learn how the language works, much like learning to speak a foreign language. For example, the first half of the statement is simply asking for every record from the table as indicated by the star or wildcard character. The second part of the statement is asking for the query to only return records where the value of the column state is equal to the term Alaska. When this query runs, only records from Alaska will be returned. SQL is a vast topic unto itself. Many people make a living as database administrators due to their ability to master the use of this query language. SQL statements are used both explicitly and implicitly in GIS software. This image shows a more complex example of what SQL can do. This statement is looking to get a count of authors by book title. This statement is using a concept of a join. This means that two tables are being combined to get one output. I'll talk more about joins in just a few moments. The output of this query is shown in this figure. In the next slide, I'd like to talk a little bit more about SQL where clauses, as these are very commonly used in desktop GIS software. SQL contains a number of what are known as where clauses. You saw a quick example of a where clause a few moments ago when I showed you the basics of a query that selected only the records where the value of the field state was equal to the term Alaska. However, many more types of where operators are available for you to determine specific criteria for a query. This image shows a variety of where operators for SQL. For example, numerical values can be determined using greater than or less than or equal. GIS is unique in that it contains what is known as spatial query operators that look at the spatial relationships for determining results returned from a query. In the next slide, I'll talk more about spatial query operators. Another way to think of spatial query operators is that of a spatial where clause. This image shows a select representation of spatial operators that are common in GIS. For example, note how this line intersecting a polygon could be how the polygon is selected in a spatial query. Other spatial queries can involve geometries that touch one another, like this example where a line segment is shared between the two shapes. I encourage you to study spatial operators to develop your spatial thinking skills that can ultimately enhance your analytical ability for working with geographic information. In this next part of the lesson, I'd like to give you a hands-on demonstration of working with query tools in an industry-standard GIS desktop environment. In particular, I'll show you how to use the Identify tool, Select by a location, Select by attribute, and Select by a graphic. Okay, so welcome to this hands-on demonstration of doing queries in desktop GIS software. What you're seeing here is the ArcMap environment, and I have a map of counties in the United States showing. Now, the very first tool I'd like to show you is real easy to use and real straightforward. It's called the Identify tool, and you can access it by finding this eye icon on the standard toolbar. And when I click on it, notice how my cursor changes to an arrow with an eye, indicating I have the Identify tool active. And if I click on one of these nice large size counties in Nevada, notice how the shape flashed green and I get the Identify window that comes up. And you can think of this as a query, as it's a very basic example of an interactive query. I wanted to know what was in this county, and by clicking on it, it gave me all the attributes associated with the feature that I clicked on. Okay, now a lot of times queries can work together with one another. So for example, let me show you how you can do what's called a Select by attribute query. Within all the U.S. counties, I have certain states. Now, perhaps I might be interested in only the counties from a certain state. If I look at this state, use my Identify tool, it tells me that its state is NY for New York. Now, you might remember from the lecture part of this video before the hands-on when I talked about SQL statements. GIS software has some basic SQL functionality built into it, and one of those functionalities is known as a Select by attribute query. Now, there's a couple ways you can get at the Select by attribute query. In this case, what I'm going to do, I'm going to go to the U.S. counties layer, I'm going to right click and select Open Attribute Table, and you can see I have all the records for the U.S. counties here, and using my example, I want only the counties where the state is equal to NY for New York. And the way I can do that is I go over here under Table Options and choose Select by Attributes. And here we see the Select by Attributes dialog that's basically building up a where clause for an SQL statement. For example, here we have a select all from the table where, and then this area here is where the where clause goes. And they've tried to make this as easy as possible for people that are not programmers or have a lot of experience with typing SQL statements. So in this case, I want to create a new selection where the field state, and I can just click on that twice, and you can see how it comes in down here, where the state field is equal to, and then if I click this button here, Get Unique Values, I get all of the unique values from that table. And so I'm going to scroll down and look for NY for New York, and double click on that term. So now I have select everything from counties where the state is equal to NY. And note that those single quotes and double quotes all are important. To make sure the statement is working correctly, you can click Verify, and that's always a good thing to see. Now let me show you if it was broken. For example, if one of those single quotes was missing, and then I hit Verify, you'll see that some kind of warning is coming up. So when that happens, that should clue you in that you need to fix something with your SQL statement. So I put the single quote back, and then I hit Apply. And if I look over here at my table, see how it says 84 of about 6,000 selected. If I click this button, Show the Selected Record, now I'm only seeing records, about 84, that are from New York. If I close the attribute table and I go back and look at the map, notice how now everything from New York State has been highlighted in blue, indicating that it was selected by the Select by Attribute query. So that was an example of using SQL where clauses, but let's look a little closer now at how you can look at spatial relationships for queries. If I zoom in a little closer on New York State, and I note the cities, and maybe I'll make those a little bigger so they show up more. Make them red. Perhaps I might be interested in having only cities that are within New York State. And the way that you can run that kind of query is called a select by location query. And to use that query, I go back over here to selection, select by location, and I get this dialog that'll guide me through running this query. So this is also an example of showing you how various querying methods work together. So let me talk you through this. So we want to select features from cities, and we're selecting cities in relationship to the U.S. counties. Now take a look at this. Use selected features 84. So I'm telling it that I only want the cities that are going to be within the selected counties of New York. So I'm going to check that box here. And then, as you might remember from the lecture part of this video, here's all the various spatial query operators or spatial selection methods. So I pick from a very big list of options here. And in this case, I want to select this one, are completely within the source layer features. So that means I only want the cities that are completely within the selected counties shown on the map. So when I hit apply, the query runs, and if you look closely, these two cities that were red are now also blue as they've been selected. And if I go look at the attribute table for cities by right-click, open attribute table, you can see I have 2 out of 606 cities selected. And when I do the show selected records only, I'm seeing Rochester and Buffalo as the selected cities. Now, it's also important to understand how to clear your selection. Right now, both the counties and cities have selected records shown by blue, and you can clear that by going Selection, Clear Selected Features, and when I do that, all of the blue will disappear as I'm unselecting all of those records. Now, one last thing I want to show you in terms of an interactive and also graphical query is the idea of selecting by a graphic. Now, this can be very handy when you don't know exactly what attributes you're looking for and so forth. Perhaps you just visually know what you want to select, and there are ways that you can do that interactively. So the first thing I need to do to make that happen is I need to bring up what's called the drawing toolbar, and to do that I'm going to go Customize, Toolbars, Draw, and it brings up this toolbar, and I'll dock that over here. Now in this example, if you look roughly at this area here, here you see a green for New York and sort of a yellow for the next state called Pennsylvania. Let's say hypothetically I want to select counties that are on the border of these two states. Perhaps there's a new pipeline, a new road that's going to be crossing back and forth between the two states, so I need to have only those counties. Now by using a graphic, I can explicitly pick just those counties. So using that drawing toolbar I just brought up, I'm going to go over here and select Polygon, and I'm going to trace sort of a rough polygon that touches counties along the borders of these two states. So all I'm doing here is just clicking, and you can see this is what they call the rubber band is forming of this polygon shape. And I double click to end it. And you can see now I have this sort of yellow blob of a polygon, but it's touching those two border counties between New York and Pennsylvania. Now if I go to Selection, Select by Graphics, it's basically going to run an intersect query of any of the features that are touching that polygon I just drew. So if I hit Select by Graphics here, notice that it highlighted just the counties between New York and Pennsylvania. In fact, if I move that graphic out of the way, you can see this a little clearer. So keep select by graphic in mind whenever you need to interactively and visually make a query. Another very important concept in GIS related to queries is that of table joins. This is another concept that comes from regular database management, but has been adopted into the GIS context due to the fundamental nature of data management when working with GIS data and software. The basic idea behind table joining is where two tables are combined based on a common field in both tables. For example, imagine that you have two tables related to land type. The first table contains the geographic features of land type polygons. The land type category in this table is referenced by a code. The second table contains the textual description of the categories and the land type code. Thus, the two tables share the land type code field in common. This will allow the two tables to be joined to one another. Once the two tables are joined, a new combined table is created that contains the attribute fields or columns from both tables. Joining spatial features to attribute tables is a very common way for creating final map products. In the following part of this lesson, I'll give you a brief example of this idea. In this example, you see the same two tables that you just saw. One is the table containing polygon geographic features of land types. The other table contains textual descriptions of the land type. Also, like you just saw, the two tables share the land type code as a common field. When these two tables are then joined together, the combined attribute table can be used for making a more readable map. For example, if you look at this image, notice how the legend is showing the textual description of the land type as opposed to the land code. Displaying just the land code number would not be intuitive to the map user. Therefore, it is important to use the table join when making a final map product that can have a meaningful legend. As one last comment on the idea of table joins, note that joins with common fields can be based on either numbers, like the examples I have shown, or using text strings as the common field. Spatial joins are the idea of combining attributes from multiple tables based on spatial relationships between geographic features of the tables. This idea is best explained visually, as I'll do in the next part of this lesson. In this image, you are seeing two geographic data sets. The first one are wetlands, shown as blue polygons. The second are roads, shown as red lines. In this scenario, I'm interested in having attributes from the wetlands appended onto the attributes of the roads. I might be interested in doing this to consider how roads are spatially related to wetlands for environmental impact. If we look at the attribute table for the roads, notice how I have the name of the road but nothing else. If I look at the attribute table for the wetlands, notice I have a wetland code. The wetland category codes are also shown as numbers on the blue polygons on the map. When I run a spatial join command, the GIS software will create a new geographic data set based on the roads. As you can see in this new updated map, the new geographic data set based on roads and created by the spatial join command is shown as a green line. When reviewing the attribute table of the new geographic data set, note how the table contains both the names of the road and the wetland category code, or a combination of the two previous tables that was created by spatially joining the tables together. One last important concept is the idea of relate. A table relate is the idea of defining relationships between two tables. An important part here, however, are that the tables are not combined or appended like a join. Relates are often used for what is known as many-to-many relationships, or when many records from one table might relate to many records in another table. In the following part of this lesson, I'll give you a hands-on demonstration of relates in addition to table and spatial joins that you learned about previously. In this part of the lesson, I will give you a hands-on demonstration of table joins, spatial joins, and table relates. In this demonstration, I want to show you the basics of table joins, spatial joins, and relates. Now, to set up a table join, you often are going to work with either, say, a Microsoft Excel or comma-separated file. So in this case, I'm going to first bring over a shapefile of US states, and this is a real straightforward data set here. And if I look at the attribute table of the US states, you can see I really don't have much. I have a code and a name for the state. Now, of course, there's going to be a lot of other attributes I might want to bring over to work and make maps with this kind of data. And for this example, I have population counts of rural and urban people by states. And these are in the form of a Microsoft Excel spreadsheet, which when you expand out the spreadsheet, you'll see that I have sheet 0, which is just a default name of a sheet in the underlying spreadsheet. And so what you do is you drag that sheet over into ArcMap. Now when I go to take a look at that Excel sheet that I just brought in, I can right click and do open its table. You can see here that I have a geo ID, the name of the state, and then some numerical data, the total population, urban population, and a rural population. If we take a look at the attribute table for the US states and compare that with the population sheet, you can see where I have a common field like I talked about in the lecture part of the lesson. For example, a code for the state, a textual description for the state in the shapefile, and then the population data I have similar. The geo ID is the equivalent of this. These two are the same, and so forth. So these give me those common fields that I can use to do the join. Now the join itself is not that hard to do. In this case, I want to join the population data onto the states. So I go to the layer and I right click and I select joins and relates and join. And I'm going to pick join attributes from a table, the field this layer will be based on, and I'll use the state, that's that numerical code. And now you can see that ArcMap already knew that I wanted to probably use the sheet with the population data, and it knew to also pick the geo ID, although I can also pick some of the other things. Now it can help to do what's called the validate join to make sure that this will work correctly. So when I click this button here, it checks to see how the join will turn out, and in this case it looks really good. 52 of 52 records from both tables will be joined together. So when I go and hit OK, you don't actually see anything happen. However, if I go and right click on US states and look at the attribute table, you can see now that the columns or attribute fields from the population data has now been joined onto the states. So that allows me to now look at various population counts by state that I was not able to do before. So as a quick example, now that I have rural population, for example, I can make a quick thematic map of that data. If I were to right click on US states, go to properties, symbology, quantities, and when I go now for value, you can see that all that numerical data is showing up as an option for me. So I'm going to hit RPOP for rural population and just take all the defaults for this quick example. And then when I hit apply, notice now I can make a thematic map using the data that came from my table join. Okay, in this demonstration I want to quickly show you the spatial join, and what you're seeing here is ArcMap GIS software, and I'm actually using the same data sets I used for the lecture part of this video where I talked you through the spatial join. And if we zoom in this area, what you see here in blue are wetlands and the red lines are roads, and what I'm interested in doing in this case is having attributes from the wetlands table added to the attributes of the roads based on their spatial location. So for example, the roads have a lot of basic things about the roads, the name of the road, its classification, and so forth. However, I'm interested in also having some of these attributes of wetlands that are near these roads. Okay? So make note of these fields in this table, as in just a moment fields or attributes from this table will be joined on by a spatial join. Spatial join is also very easy to do in that you right click on your layer of interest, joins and relates, and then join. Now in this, to do the spatial join, you have to change one thing up here. Instead of joining attributes from a table, you're going to join from another layer based on spatial location. Okay? And I've only got one other layer in here. So the layer to join is going to be Monroe County Metlands, and we're going to join polygons to lines. And this is an optional thing to give some kind of statistic. However, I want attributes added to the lines from the polygons that are closest to it. And again, this could be something that you determine based on your needs, but in this case I'm just going to look at closeness of the wetland to the line for determining how the attributes are spatially joined. So I select that, and this actually creates a brand new output file as opposed to appending data onto a previously existing file like you saw in the table join. So this could be important to know where your output's going to go, but for this example I'll just take the default. I'll hit OK, and you can see here, if I zoom in a little closer, that we now have a new layer was created called join output. That I'll make it a little bigger and more visible so you can see it. And when I look at the attribute table of this output, you can see that all the fields from the roads are still there. However, we now have all of the attributes from the wetlands are also part of this table based on the relationship that was found between the roads and the wetlands through the spatial join. The last thing I want to show you now are table relates. As a reminder, table relates are ways that you can store relationships between one-to-many or many-to-many tables. In this example, you can see I have counties from New York State shown as polygons, and then I also have points of what are known as National Register locations. National Register locations are sites of historical importance. As you can see, there are multiple National Register locations in one particular county, and a relate would be a good way to have that relationship stored in an attribute table. Now, to set up a relate, let's look at the tables first. So I open the attribute table of New York counties, and I open the attribute table of the National Register locations. You can see that the counties basically are just giving me reference information, the name of the county, what state it's in, identifier codes, and so forth. If we look at the National Register points, you can see I get more information, the name of the resource, where it's located, and so forth. Now I also have things like county information, and what I'm going to do in this case is I have this column here called County SHO for county short, and that just gives me the textual name of the county, and that the equivalent county in the National Register is called county. Again, just a short one-word description of the county. So what I want to set up with the relate is whenever I click on records from a given county, I want to see all of the related records of National Registers in that county. And it's not very difficult to do. All I have to do is if I go to New York counties, right click, joins and relates, and then relate, and I just pick the fields to base the relationship on. So in this case, I'm going to pick county short, and I'm going to take National Register because that's in my map, and I'm going to look for the county name here. And you can give this a relate if you want. I'll call it NR for National Register, and I'll hit OK. And again, you don't really see anything happen. However, what this did do was create a relationship between New York counties and National Register points. So for example, this county here is called Monroe County, and just by looking at it, it looks to be about 50 National Register points there. When I go and click on Monroe County using my Identify tool, I get basic information about that county. However, when I click and expand out, notice now I've got a subtree of all the National Register points, and they even flash green when you click on it, and you get a list of all the different National Register points that are related now to the counties. And you can see when I'm clicking on them that they'll flash and highlight on the map. So keep relates in mind whenever you have one-to-many or many-to-many relationships between two tables. In this lecture, you learned about how to describe what a spatial query is in terms of SQL statements and spatial query operators. You also learned how to describe what table joins and relates are. Table join is a core GIS concept that will allow you to work with a wide variety of data sets. Finally, I showed you how to compare and contrast various spatial querying, joining, and relating techniques through practical demonstration using ArcMap GIS software. As you saw, performing joins and relates are not difficult. However, it is important that you learn to master the concepts behind joins and relates so you can use them effectively. The following are references used in preparing this lecture. If you enjoyed this GIS tech video or have any comments or questions, feel free to contact me at the email address below. Thank you for watching.